Okay, we are going to finish off this review worksheet. So, looking at here, we have a number 35, an angle of elevation is actually what's being described here. So, we have a height, making sure I see the problem here. I have a height of 63 meters for the building, and then there's an angle here of 45 degrees, 30 minutes, which is right in there. So what we're supposed to do here is find the length of the wire. So that's actually going to be the hypotenuse. So what we have here is the angle, and from the angle we have the opposite side, and then we have the hypotenuse. So that's going to be the sine of 45 degrees, 30 minutes, equals 63 over x. So from the SOHCAHTOA, we are using SO right now. Opposite over hypotenuse. So looking here, again, this is the situation where you would multiply both sides by x and then divide by sine 45 degrees, 30 minutes. That's just a number, remember. So eventually we're going to see that these two switch places. So this is going to be x equals, and then 63 divided by sine of 45 degrees, 30 minutes. So now I'm going to take you over to the calculator on the side here, and we're going to type all this in from our calculator page. So we have, we have 63 divided by, and in parentheses, I'm going to put the sine of 45, and if I hit Control book here, we can see we can get the degree symbol to come up, and then we do, it was 30 minutes, so 30, hit Control book again, and then over here is the minute symbol. Okay, so we have that, and if we hit enter, we can see that our answer is going to come out for the length of the wire to approximately 88.33, and we don't want to forget our units, in this case meters. Alright, moving on to the next one. What we want to do is we want to draw an isosceles triangle, because that's what the problem is talking about. So I'm going to make those two the congruent legs, and we're supposed to find the altitude. So then we're going to drop down an altitude, not in all triangles, but in this triangle, an isosceles triangle, the altitude will divide it into two congruent triangles. So actually what we have here is this segment congruent to that segment. Alright, well we have a base of 184.2. So what I'm going to do is I'm going to divide that by 2, and I'm actually going to get 92.1 for this double tick marked portion, which is half of the base of the isosceles triangle. And then the angle opposite the base, so if this is the base, then the angle opposite the base is 68 degrees 44 minutes. Well, what I'm going to do is I'm going to also divide that by 2, and you'll see that I'm going to get 34 degrees 22 minutes for that angle. Now what they're doing is telling me to find the altitude, so I'm going to call that x, and here we are again. We have this angle here, the opposite to that angle, and then over here would be the adjacent to that angle. So we're actually starting to hopefully learn that that would be opposite over adjacent, so that's the tangent function. So tangent of 34 degrees 22 minutes is equal to opposite 92.1 over x. So I'm going to save some time here because this is basically what we just did on the last problem, but again, when you solve this and go on the calculator, you're going to get approximately 134.68 centimeters. All right, number 37. This is going to be a good practice for us for seeing that how to find an actual angle when it's unknown in an application problem. So a ladder, thank you, great ladder, is placed against a house. All right, so that its base is 9 feet from the house. So this right here is 9 feet. What angle does a ladder make with the ground? So that's going to be our theta right here. So when we look at this here, we have theta here, 9 here, and then what we're looking for is what angle does it make? The one thing I didn't write on there is, sorry, it's a 16-foot ladder. So that's going to go right here. So I'm going to grab my pen back and put a 1 and a 6. So what is this though? It's not opposite, it's adjacent, and it's hypotenuse. So we're getting practice here, adjacent and hypotenuse. So hopefully we're knowing that's ca for cosine. So the cosine is always of an angle, so this time theta is equal to 9 over 16. Now remember, this isn't a mathematical operation. What it is here is you're saying, okay, I want to find theta, calculator. Could you please tell me? I know, calculator. And that's what we're doing when we say the inverse cosine. I know that the ratio of the adjacent side to the hypotenuse is 9 to 16. Can you please calculate for me what theta is? And that's what we're going to go do on the calculator. So, trig, and we do want to use cosine inverse since we're looking for that angle. And then we're going to type in 9 divided by 16. We're going to hit enter. And then we get the 55.77, but we want to DMS that. So I don't know if this one is set up for that. I'm going to go to my book. And I'm actually going to go click this first tab. There's 5 tabs along the top. I know this takes a little bit of time on your calculator sometimes, but if you click that tab and then you, you scroll all the way down, which is hard to do on this. Alright, let's try this again. Sorry about that. So I'm going to go to my book, and in here I'm actually going to type the letter D because that should get me closer. And it goes down my list, and I'm looking for converting to degrees, minutes, and seconds. There it is. So I want to click that, and that should stay there the next time I want it. But clicking that is what I wanted to do. I wanted to take my answer and convert it to degrees, minutes, and seconds. So hopefully that'll work out okay. And then we're going to see that it's 55 degrees. And then looking over here, it's 46 minutes and 16 seconds. 16 is not enough to bump it up. Remember, the halfway point is 30. It's not 50. Since there's 60 seconds in a minute, we got to look at that halfway point of 30. So it doesn't bump it up still, and that would be 55 degrees, 46 minutes. Okay, so those last 3 examples are really good examples on how to use the different trig functions. Okay, now when we jump to 38 here, this is a tricky problem. It's actually a problem that involves finding a calculation to move on, and it's being a little bit more specific. So as we look through this problem, hopefully you've read through it, but we have, and I will do my best to draw this picture here, we have a person standing on the edge of the bank of a canal, observes a lamp post on the edge on the other side. So we're going to put this lamp post up here. Let's see here, make this. Alright, there we go. And what happens is if you have this person looking straight across, they would be looking straight here, okay? But the problem describes the person's eye level here is 5 feet above the ground. Well, just remember that that's going to be the same over here. That's going to be a point 5 feet above the ground. the angle of elevation from eye level to the top of the lamppost. So elevation is looking out and then looking up. So the elevation to the top of the lamppost here is the 12 degrees 30 minutes. Alright, so I'm going to try to write this in there. This may get tricky. 12 degrees 30 minutes. Okay? And the angle of depression from eye level to the bottom of the lamppost is 7 degrees 15. So here, looking up, angle of elevation, and then looking down to here is the angle of depression, which we have given to us as 7 degrees and 15 minutes. Now don't continue until you understand what we just did there. And there's a lot of info going on here. But now, how high is the lamppost? Well, hopefully you can see that this is creating a right triangle above and a right triangle below. So to first find, well, there's, it depends on which one you want to find first, but if we try to, if we try to find how high is the lamppost right now, I guess you would need this value, right? So you would need this here, so you could add 5 to that value. Well, when I try to do this, I have one angle here. I don't know that. I don't know the hypotenuse, and I don't know this. So if I try to do the lamppost right away, I don't have enough information. But one thing I can find right away is how wide is the canal, because the canal would be from my eyesight across here. So I can actually find X, if I label it that, right across here first by using the bottom triangle here. Alright, so once again, I don't know if this is helping you by highlighting these, but I have this angle, I have from that angle the opposite, and then here I have the adjacent. So what that is tangent. So what we're going to start here is we're going to say tangent of 7 degrees 15 minutes is equal to opposite, which is 5, over adjacent, which is x. Alright, so again, I'm going to save a little bit of time here and let you guys do your calculations if you need to pause it, but those two would switch, so it would be 5 divided by tangent of 7 degrees 15 minutes. And then x is coming out to approximately 39.30 feet. Actually, I'm going to actually do this calculation here because I want to show you something in a minute that I just thought of. So I'm going to take 5 and I'm going to divide by, I'm putting this in parentheses, I don't think you have to, tangent of 7 degrees and 15 minutes. Okay, so there we're seeing that value of 39.3032, but I'm going to keep that value there. Now, I have that value here, okay? So what I'm going to do is I'm going to highlight this in green without rewriting it. That value right here is this value now, all right? So what I'm going to do is I'm going to use that because I now have, when we're looking at this, I now have an angle, and I'm trying to find just that, and I have this one right here. Okay, so that's going to be, and I got to call that a different variable at this time, and I'm going to call that y. So now I'm going to take, what would that be? Opposite and adjacent. It's still going to be tangent. So I'm going to take the tangent of 12 degrees 30 minutes, and I'm going to set that equal to y over, and I'm going to write here 39.3. I'm not going to use the value 39.3 though. I am actually going to use the value stored on my calculator. So if I multiply by this value of 39.3 to both sides, I would actually get this value here for y. So what I'm going to go to my calculator and do now is I'm going to click up, and I'm highlighting that value we just got, and I'm going to hit enter to bring it down. I also could have just clicked times because that would have given me my answer here, but I'm going to multiply that by the tangent of 12 degrees, 30 minutes. Give me a second here. When I do that, I get my value of 8.713. So that's going to tell me that my y value is equal to 8.71. Now, don't get too excited. That's not the answer. That's just the y value. So there's two answers to this problem because there's two questions. How high is the lamppost? Not 8.71, but what we want to do is we want to add 5 to that because that's this area plus the 5, 13.71 feet. And that was the trickier part of this problem, was finding that. Now the other question, how wide is the canal, we already answered for our x value. Okay, now we're going to finish it strong here. This is the last question. There's a lot on this review, but this is a very important chapter. Right triangles and trigonometry is very important. All right, so the last one here, there's easy parts and there's little difficult parts to this. Number 39, we have to first find the sum vector. The sum vector is actually adding together the components of two vectors. So the sum vector here would be equal to, in component form, we're just going to take, and we're going to, most kids don't have a hard time with this, we're going to take those two values, 1 and 13, and we're going to add those together. So that becomes 14 for my horizontal component, and then 2 plus 7 would be 9 for my vertical component. Okay, so I'm going to draw a picture of this just so we're looking at it. That would mean if I'm starting here, what I'm doing is I'm going from here to the right, 14, and then I'm going up 9. Okay, so I'm actually writing out these values. Now, the actual vector here is right here. Okay, so that is my actual vector, but I'm showing you the directions here and showing you just that you can see that there is a reference right triangle here. Okay, so now, really want to highlight these. I really want to make sure you understand what this question is asking. Find the sum vector. Got it. That's it. That's the sum vector. Determine its magnitude. Okay, so the next part of this question is saying find the magnitude. Well, the magnitude of the vector is the same thing as actually just calculating the length of the vector. Now, we have talked about distance formula with this, but I don't have these ordered pairs right here. Sure, you could make one up. You could make this 0, 0, and you could make this one 14, 9. But it's easier just to think of it as a right triangle. Okay? So over here, I'm just going to kind of highlight here first the notation for finding the sum vector's magnitude is, it looks like the absolute value symbols. So this is actually the sum vector's magnitude that we're about to find, and that's equal to the square root of 14 squared plus 9 squared. Okay? Now, looking at this, it might have been a big jump for some of you, but I want you to understand that's literally like the Pythagorean theorem. 9 squared plus 14 squared equals c squared. And then you're going to end up taking the square root of both sides to get here. Now be very careful. You cannot mathematically cancel the square root with the square since there's a plus here. Okay? But this actually equals the square root of 277, which actually comes out to approximately 16.64. Okay? So that is the magnitude that we're talking about with this vector. All right, so find the sum vector, determine its magnitude, and then now the kicker is on this one, you want to find its direction relative, sorry, I meant to get a highlighter there, relative to east. Okay? That's what we were looking for, the direction relative to east. So really, how do we do this? Okay, let me try to maybe get some reference on here. If I were to draw north, south, east, and west right now, where is east? Okay, well, east would be this direction, right? This is east. So relative to east, if we were facing this way, where is the vector? The vector is above or north of that. So this is the angle that this problem is asking for. And we're going to call that angle theta. Okay, so I want to stay on the relative to east for a minute, just because this is where a lot of kids make mistakes. If I'm facing east, this angle is north of east. I literally swing north to get to that vector. Now, if it said relative to north, then we would face north here. This is the direction we would face, and then we would go which way? East. So it would be east of north. But this one is actually north of east. You really want to practice a bunch of these until you get it. So now it says give both types. That's what they're asking, both types of answers. That's the two we've discussed in class. So the first thing we need to do is use our trigonometry. So we're going to get some more practice here with tangent. So tangent theta equals 9 over 14. And then using our inverse trig, because we know the ratio, we would do theta equals the inverse tangent of 9 over 14. So theta is approximately, and I'm going to let you go ahead and calculate that and DMS it, but it comes out to 32 degrees and 44 minutes. Now, we're not going to lie to you. We are happy if you can find that angle, but as far as these vectors go, 32 degrees 44 minutes without the direction means nothing. I could go this way, I could go that, I could go in many different directions here, so you need to tell me which way. Well, again, like we've been discussing, this would be 32 degrees 44 minutes, and which direction? That would be north of east. All right, and the other way we talked about writing this is 32 degrees 44 minutes, and we just write it like this. We keep reading north of east, and we come back to the beginning to put the E. So the hint I've given you is to start reading with the angle measure. So 32 degrees 44 minutes north of east, 32 degrees 44 minutes north of east. Okay, now the last thing I want to say is some of you might find the complementary angle here. That complementary angle is absolutely a correct answer if these directions relative to east were not there. So find that angle, fine, but that would be relative to north. All right, so my last final thing I'd like to say to you is that I hope you've enjoyed this video or these videos, and I hope you have great luck on your test tomorrow, even though it might get a little bit triggy. If it gets a little triggy, just squiggle your way to the end of the test, or you can use your special right triangles, or don't forget, it's all about our families.